Hi, I'm Jelle.
And I'm Bram.
Yeah.
Green software.
Green software. I've read a book.
I like books. Tell me.
It's called Building Green Software, and I got enthused. I got activated, and I was like, okay, I need to share this because this is not just relevant for the tree-hugging hippie or even the environmentally minded person like me. Yep. It's relevant for anyone who cares about quality code. So
quality, okay, green and quality. Now
green and quality.
You got me.
Good.
Let's go.
All right. So let's start with the benefits. So this is like the book mentions a lot. I have some experience with this. I do have some experience as a green consultant. I think it's an upcoming business, so. Which is another reason, not mentioned here on the slide, but why I think companies need to look into this. I think this is going to become bigger and bigger. You might want to get ahead of the curve. So besides all the tree hugging and plant kissing, because I think saving the world should be enough of a reason, but why should we care about going green in software? So
now to do it.
Green software tends to be more reliable and more resilient.
Okay.
Most of the reasons tend to be you need to analyze, do a lot of analysis, and if you want to build green software, you need to think about how to design your software more. That tends to lead to more architecture, more deliberate choices, which tends to lead to more reliability and more resilience. Also because green software and lean software, they're really close together. So if you lose all of the additional smug, you tend to have more reliability. And it tends to become cheaper to operate. We tend to get more secure code, especially because if the most secure software is software you haven't written, green software tries to keep it as, you want to try to keep it to the minimum viable product that's needed. That's easier to secure. There's a lot less in it.
Is that also basically saying that you want to avoid over-engineering?
Always.
Always,
yes.
Okay.
That's a very good summary.
Okay.
Green software tends to be more performant.
Yeah, that's good.
Because a slow performance is not only really annoying, but it's really bad for the environment, because if you have to wait for something, that means that the server is doing something really inefficient.
And expensive.
Bad for the environment. And finally, if you're going green, then you don't want to store any data that's useless. So finally, you have another, besides implementing AI and GDPR, we have another reason to get into our data and go, we don't want to store this anymore. This is unnecessary. Let's clean this up a bit. These columns are completely waste of space. Because the less data you store, the greener you are.
Okay, so how do you handle this with single responsibility? Sometimes it's needed to have one column into databases, for example. That's fine. The best green software is not just the one that causes the least amount of carbon and toxic waste and stuff. The best green software is software that does what you want your software to do. Yeah. Plus being as green as possible. Okay. So if you need a one-column table somehow, then you need a one-column table. Yeah. If you need a 100-column table, and that's the most efficient way to do it, good, you find out. So it's not about duplication is bad, it's be efficient.
Correct, because sometimes duplicating data might be the most efficient and green way to do what you want to do. So we have carbon efficiency and we have carbon awareness. And carbon efficiency is basically getting the most out of your carbon, and carbon awareness is knowing that carbon that your output is not the same across time, across spaces, because energy tends to be greener. Let's say in Scandinavia. Yep. So stuff like that matters, and designing your application to work like that and to be being able to leverage these kinds of problems or challenges. That's how you design green software. Stuff like queuing, stuff like scheduling, stuff like storing data for later potential use in a place where the storage is at its cheapest and greenest, stuff like that. Okay, so being conscious about it, you can program an AI or some trigger to trigger when when energy is cheap, so to speak, instead of during the night.
billing process, for example? Just do it when it's convenient?
Well, yeah,
or?
I mean, I think by now, at least in the Netherlands, doing your washing at night is not the most efficient way to do it anymore because of all the solar power we're using. But still, being conscious about that, that's one thing. A fun anecdote in the book is that, well, you have Jevon's paradox, which basically means if you get really efficient at something, that's bad for whatever you're trying to solve because more and more people are going to use it.
Yep.
So the fear, if we're going too green, we're going to ruin the environment, which I think it's a paradox. It exists. We've seen this in historical data. But if we're not going green, we're destroying it anyway.
Yeah.
So you might as well get all the bonus benefits of going green. And finally, there are some choices where you can use your code efficiency. You can actually, so you can think about going green on the software level, but you can also go green on the code level. Basically, go async. Maybe don't add too many calls. Don't add too many layers if they're not necessary. If you're using API calls, consider going gRPC instead of REST. And finally, we tend to use a lot of libraries.
Oh yeah.
Some libraries are very, very good, carbon efficient, carbon aware. Some libraries are terrible at it. Weigh that in your choice, not just whether you like it and whether it does what you want, but how green is it? You can. That's a very easy choice to make.
Everybody can contribute to libraries, right? Most of them are open source. A lot of them are open source. So feel free to.
Yeah. So another one that's really fun. If you're writing software, many people use laptops and phones to consume your software.
Yep.
Use them. They have hardware too. Make sure that gets used. Put some calculation, put some engineering, put some work on the client, and make sure that those machines are used as well.
Client-side rendering was a topic a couple of years back that it wasn't not done, or well, you shouldn't depend on it. But if done correctly, then
if you're
it's good.
Yes. Okay. Well, it's at least it's green, and
green,
it makes for a very carbon aware, carbon efficient model. Finally, I mentioned already, queuing is basically queue something and then operate when it's best, cost-wise, security-wise, green-wise, to actually do it. So for the operations, there's multi-tenancy. Just use your app to its fullest extent. Pick your regions. Do auto-scaling, which, when I start mentioning all these things, you're like,
Good idea.
Costs. Yeah, you're saving costs. Basically, utilize light switch ops, which is basically saying, no, we're not running at the moment, and we're running right now. That should be how easy it is. And I mentioned time and location already. So sometimes energy is cheaper, sometimes someplace energy is worse. And I want to mention shape demand here. Even if your users tend to use your application all the time, maybe you have some way to subtly influence the behavior of your user to make sure that your app gets used in a more green or more cost efficient or more secure way. Shape demand, which is really cool. So I want to mention the Green Software Foundation, which is where the book and I and a lot of people get a lot of these ideas. One important thing is being able to measure your green software. And this formula, I'm going to say, let's just go to the website, try to understand it. It is actually understandable, but not in the time we have. But this measures your CSI. So basically, how clean is your software?
Is it easy to implement so everybody can pick it up?
Great question. There's tools for that. So Azure
does it for you.
Azure has ways of being able to measure this. But there's also a carbon aware SDK where you can just add NuGet or use an API to get a measurement. There's an open source alternative to the Azure dashboard, and there's a lot of tools on Green the Web. So I think it's becoming more and more easy to just look around and see how to get those benefits without needing to be an environmental scientist. I think that was the case like 5-10 years ago. It's really hard to make green software, but the tools are slowly being delivered to us as software developers, testers, architects. And I would urge
companies and consultants and anyone doing something with software to maybe take a look and see whether there's something in it for them.
So basically you're saying there's no excuse here. It's very easy to implement and very easy to be conscious about it.
I would love to be saying that. I'm saying
too soon.
That's maybe in 3 years,
Okay.
but we'll get there. And whenever something will get very easy and widespread, maybe this is the time to look into it, because otherwise you're already behind the curve.
Right, sounds cool. Go green.
Go green. Thank you so much. Bye bye.